Hello, everyone. I'm Manaswi Saha, a computer science PhD candidate at the University of Washington, Seattle. I'll present our work on visualizing urban accessibility with the goal to understand how to design interactive visualization tools for diverse stakeholders' decision-making needs across urban planning, advocacy, policymaking, and daily living. This work was with John Froehlich, Jeff Heer, and a group of excellent HCI students. Broadly, we define urban accessibility as the ease of getting to destinations and activities using city infrastructure, including buildings, transit, and pedestrian infrastructure. We specifically focused on pedestrian infrastructure of sidewalks and associated problems such as missing curb ramps, surface issues, obstacles, and no sidewalks. We took a multi-stakeholder approach to understand visualization needs of 5 groups, including policymakers, department officials, accessibility advocates, people with mobility disabilities, and caregivers. We define people with mobility disabilities as individuals using some form of mobility aid, such as a wheelchair, cane, walker, or a stroller. The key question we asked is how might we utilize interactive visualizations to support communication and decision-making needs for urban accessibility. Accessibility visualizations help us see patterns. For example, in these point maps, urban core of DC has more obstacles, while the periphery has more no sidewalk issues. However, this is just one way of visualizing this data. Other types of questions require other forms of data visualizations. Questions such as, where are the inaccessible areas in the city? Why are they inaccessible? And where are the areas with highest repair needs? Thus, the key problem we study is to understand how stakeholders want to visualize and analyze urban accessibility data sets, and what does that mean for future interactive visualization tools. To do this, we ask 2 primary questions. What are the key visual analytic tasks and data needs for urban accessibility? And how might key stakeholders' sense-making practices differ? We recruited 25 participants across 3 cities, Seattle, DC, and New York City, and 5 stakeholder groups to do a multi-stakeholder analysis via a 3-part probe-based interview study to understand their sense-making practices, needs, and approaches to answer their decision-making questions using visualization. We used maps as their main visual construct for the design probes, where we created 24 prototypes across 7 map types, which included point maps, grid maps, heat maps, core pleth, street visualizations, and isochrones. We printed the digitally created maps on paper to conduct the 3-part interview study, which included first, an initial exploration of the map types, second, performing 3 sense-making tasks using them, and third, a brief interview to reflect on their experience and critique the utility of the map types based on their personal needs. The tasks were across finding accessible and inaccessible areas in the city to comparing accessibility between neighborhoods and between people with varied abilities. Overall, we found that one-size-fits-all won't work because design needs for each group were inherently different. Our findings demonstrate how these needs are different through an analysis of how maps satisfied their personal data and information granularity needs and prioritization needs for acquiring actionable insights. We categorized these findings across the 2 research questions we asked before. Let's see the first question around key analytic tasks and data needs for urban accessibility. We found diverse set of analysis tasks across the stakeholder groups. For example, low-level tasks such as finding sidewalk accessibility of a street or a neighborhood, to high-level tasks of assessing the impact of sidewalk accessibility on healthcare access. These tasks can be laid onto a spectrum from micro to macro level, where stakeholders operate at the primary levels with some shared tasks across the groups. For example, policymakers, department officials, and advocates asked about a mid-level task of assessing sidewalk network connectivity for making investment decisions. To support these tasks across the diverse context, Different assessment factors and metrics needed to be prioritized and balanced. For example, from using primary accessibility datasets such as sidewalk and building accessibility to complementary datasets such as demographics, income, population density, and others. To support these diverse needs, maps needed to align with their existing mental models and processes. Several factors influenced the stakeholders' sense-making practices, including their personal experiences that drove their process, contextualizing patterns being a core subtask, personally relevant assessment factors influencing the metrics that they utilized, and others. Let's focus on the first one, on how their personal experiences drove their sense-making process. We found that an individual's relation to accessibility through lived or post-professional experience, familiarity with the location being visualized, and familiarity with the map-based analysis influenced their process as well as the insights they gained. For example, those familiar with map-based analysis immediately start identifying patterns and search for specific insights relevant to their context. For example, an advocate, while analyzing connectivity using StreetViz, said, "What I'm looking for here is not just redness, but the distribution of redness across a particular area as it connects to other red markings." These familiarities in turn influence how they assess the map's utility based on their alignment with the mental models. For example, department officials preferred street visualizations as they use street as an analysis unit for analyzing accessibility in their own jobs, while MI individuals and caregivers preferred isochrones for its localized data views that conveyed experiential context with data scale closest to their daily living needs. Given these findings, in the paper, we discussed the implications for future visualization tools that cater to the diverse context with varied factors and priorities and stakeholder differences. We created a set of design considerations around this overarching question we asked in the beginning of how might we utilize interactive visualization to support communication and decision-making needs for urban accessibility. The 10 design considerations are across 5 categories, including establishing data trust, handling diverse assessment factors, supporting shared stakeholder tasks, supporting comparisons, and building persuasive stories. Each of these present interesting future research directions in this space. Please refer to the paper for more details. With this, I would like to acknowledge all our brilliant team members and my advisors, without whom none of this would have been possible. Thank you.